Hello friends, very welcome to all of you again. Today we will going to discuss on TYBCS computer networking part first network model point. In this chapter we have to discuss about network model, which is covers ISO OSI reference model and TCPIP model. In last video we have seen hardware and software of a network that sends the data from one location to another. For that purpose there are few layers are work. Each layer at sending and at site uses services of the layer immediately. Network model define a set of network layers and how they interact. There are several different network models depending on what organization or company started them. The most important two types of models here. There is OSI network model. In the international standard organization, that is ISO, has defined a standard called open system interconnection, that is OSI reference model. This is the 7-layer architecture listed in the next section. This model is dominated data communication and networking literature before 1990. The OSI model was never fully implemented. And the second model is TCP/IP model. It is also called as Internet model because TCP/IP is the protocol that is used on the network Internet. It is basically used in Internet. The TCP/IP protocol should become a dominant commercial architecture because it was used and tested extensively in the Internet. In the next two sections, we will discuss two important network architectures: the ISO OSI reference model and TCP/IP model, layer of these models and functions of each layer. OSI model, that is OSI reference model, was established in 1970 by the International Standard Organization, that is ISO, which is the multinational body dedicated to worldwide agreement on the international standards. The model is called ISO-OSI, that is Open System Interconnection Reference Model, because it deals with connecting open systems, that is systems that are open for communication with their systems. The purpose of OSI model is to show how to facilitate communication between different systems without requiring changes to the logic of underlying hardware and software. The OSI model is not a protocol. Remember that it is the model for understanding and designing the network architecture that is flexible, robust, and interoperable. The OSI model is a layered framework for the design of the network system that allows communication between all types of systems. The OSI model has 7 separate but related layers. The principles that were applied to arrive at the 7 layers are: a layer should be created where a different level of abstraction is needed. Each layer should perform well-defined function. The function of each layer must support internationally standard protocols. The layer boundaries should be chosen to minimize the information flow across the interfaces, and the number of layers should be sufficient one. There are 7 layers as shown in figure. First one is physical, second is data link, third is network, fourth is transport, fifth is session, sixth is presentation, and seventh and last layer is application layer. In these first 3 layers, that is physical, data link, and network layer, are called as hardware layers. Transport layer is called heart of OSI, and last 3 layers, that is the session, presentation, and application, are called as software layers. we have to see the function of each layer. Each layer has its own functions. Physical layer, this is the lowest or the first layer of OSI model. This layer coordinates the functions required to carry bit stream over a physical medium. Physical layer deals with the mechanical and electrical specification of the interface and transmission medium. It is concerned with individual bits from one node to the next node. It has data encoding, data rate, bit synchronization, line configuration, physical topology, and transmission mode. Second layer is data link layer. This is the second layer of this model. Data link layer is responsible for moving frames from one node to next. Data link layer transforms the physical layer, a raw transmission facility, to reliable link that is error free and gives to the network layer. For that purpose, it is divided into two parts: MAC, that is media access control, and LLC, that is logical link control. The function of data link layer is framing, physical addressing, flow control, and error control, media access management, and last one is access control. Third layer of this model is network layer. This layer is responsible for the delivery of individual packets from source host to the destination host. When source and destination are from the same network, there is usually no need for network layer. Delivery of packets is handled by data link layer. However, if source and destinations are from different network, the network layer is responsible for delivery of data packets. Other function it has like logical addressing, routing, congestion control, and internet networking. Fourth layer is transport layer. Transport layer is responsible for the process to process delivery of entire message. A process is an application program running on host. Network layer is not able to recognize the relationship among the packets. Though the packets are from one message only, it only performs source to destination delivery. It treats each packet independently. The transport layer, on the other hand, ensures that whole message arrives, interact, and in order, overseeing both error control and flow control at the source to destination. It has other functions like port addressing, segmentation, reassembly, connection control, flow control, and error control also. Next layer is PIP number, that is the session layer. This layer is the primary responsibility of beginning, maintaining, and ending the communication between two devices, which is called session. It also provides for orderly communication between devices by regulating the flow of data. The session layer is the network dialog controller. It establishes, maintains, and synchronizes the interaction among the communicating system. It has functions like dialog control and synchronization. Sixth layer is presentation layer. This layer is also called as a translation layer. In presentation layer presents data into uniform format and marks the difference of data format between two dissimilar systems. The presentation layer is concerned with the syntax and semantics of the transformation transmitted between two systems. Presentation is layer is responsible for translation, compression, and encryption also. And the last layer of this model is application layer. This is the 7-number layer that enables user, that is human or software, to access the network. It provides user interfaces and support for services like email, remote file access, and the transfer. It shared the database management and other types of distributed information services. It is also responsible for providing the services to the user. It also gives function like network virtual terminal, file transfer, access management, mail services, and directory services also. In this way, this layer is work, and this is the overall presentation of OSI model. Our next point is that TCPIP model, the ARPANET research network, which was developed by US Department of Defense and connected with hundreds of universities and government installations using lease lines. When satellite and radio networks were added to these network, compatibility issues arises. The exciting protocols are not compatible with new network, so no communication in between old and new network. A new architecture is needed which is connect multiple network in seamless way. A flexible architecture was needed since application with diverse requirements were envisioned, ranging from transferring files to the real-time speech transmission. This architecture was developed and known as TCPIP reference model. TCPIP stands for Transmission Control Protocol Internet Protocol. TCPIP model is also called as Internet Reference Model. It is the set of protocols or protocol suite sorry, that defines all transmissions and exchange across the network. In this model, there are four layers: host to network layer, internet layer, transport layer, and last one is that application layer. In host to network layer, it is the first layer of four layer TCP/IP model. This layer corresponds to the physical and data link layer of OSI model. Host to network layer defines details how data is physically sent through the network, including bits are electrically or optically signaled by hardware devices that interface directly with the network medium, such as coaxial cable, optical fiber, or twisted pair copper wire. The protocol included in host to network layer are Ethernet, token ring, FDDI, X.25, and frame relay, etc. Second layer of this model is internet layer. This is the second layer of this four layer protocol. In internet layer, data pack data into data packets known as IP datagrams, which contain the source and destination address, that is logical address or IP address, information that is used to forward the datagrams between host and across the network. The internet layer is responsible for routing the IP datagrams. Internet layers job is to allow host to insert packets into any network and have them to deliver independently to the destination. The main protocols included in the internet layer is the IP, that is Internet Protocol, ICMP, Internet Control Message Protocol, ARP, that is Address Resolution Protocol, RARP, that is Reverse Address Resolution Protocol, and IGMP, that is Internet Group Management Protocol. The third layer of TCP/IP model is transport layer. This is the third layer. The purpose of transport layer is to permit devices on the source and destination host to carry on conversation. Transport layer defines the level of services and status of connection when transporting data. It is designed to allow peer entities on the source and destination host to carry on a conversation. We call it is end-to-end communication. For that purpose, there is two protocols: TCP, that is transmission control, and UDP, that is user datagram protocol. TCP is reliable connection oriented protocol and UDP is unreliable connectionless protocol. And the last layer of TCP/IP model is application layer. We know that application layer is the topmost or the last or the fourth layer of TCP/IP model. That defines TCP/IP application protocol and how host programs interface with transport layer services to the user network. Application layer includes all the higher layer protocols like DNS, domain naming system, HTTP, that is hypertext transfer protocol, telnet, SSH, FTP, that is file transfer protocol, TFTP, that is trivial file transfer protocol, SNMP, that is simple network management protocol, SMTP, that is simple mail transfer protocol, DHCP, that is dynamic host configuration protocol, X Windows, RDP, that is remote desktop protocol. In this way, TCP/IP model works. I hope that friends you have understand these two models, that is ISO-OSI and TCP/IP model. Thank you so much.